Hi, everyone. Thank you. I am thrilled to be here. I did just come from Nairobi. I lived in Kenya for about a year, many years ago, but this is my first time here in South Africa, so it's great to see so many people. Are you guys all awake? Anybody need to stretch or anything? So I am excited today to talk to all of you about the future of architecture, engineering, and construction. So we heard about the future of making, we heard about what's happening in the design and manufacturing space, now talking about AEC. And it's an exciting time, especially being here, and we, all of us collectively in this room, have an opportunity to really reimagine the future of what gets designed and built here on this continent of Africa. So I do lead sustainability at Autodesk, and in that role, I think a lot about the future. And my colleague Walter talked about the fact that by 2050, there'll be 10 billion people living on this planet. What a lot of people don't realize is that 1 in 4 people will live here on the continent of Africa. And the population of Africa is going to double from 1.2 billion to 2.5 billion people in a matter of decades. And most of those people are going to live in cities, many of which haven't even been built yet. So when you think about the trillions of dollars of investment in infrastructure, it's an enormous opportunity. So today we're going to talk about who's going to be designing that future and how it's going to be designed and built. So we heard about Van Wynen. We heard about how this company is reimagining their business, embracing automation and generative design. And there's many other companies in the construction space that are also starting to embrace and take advantage of practices that were commonly found in the manufacturing sector. So today, we're going to talk about the convergence of construction sites like you see here with manufacturing. And the good news is that as this convergence happens, our research is showing us that we'll increase productivity by 30%, being able to design and build more things, reduce waste by 90%, which has enormous cost savings, but we'll also be able to reduce injuries by a factor of 4. So we'll talk about how we're going to get to that future where we converge construction and manufacturing. So imagine how you might change the way you think about design, engineering, and construction if what you're working on is built off-site, in a factory, where the components and modules are manufactured and assembled. As you watch this, imagine how your industry might change from the factory and then taken to the construction site to be for final installation, as you see here. Imagine how that might change your industry. We call this the manufacturing of buildings, and this is the next big disruptor in our industry. And it's radically going to change how we design our buildings, how we make the components, and how we assemble them on site. And it's going to require a transformation for all stakeholders, from designers, engineers, fabricators, contractors. Everyone is going to have to learn new methodologies and new ways of working. So we're going to take a look at each aspect of this idea, and then later we'll hear from a customer, Bogardman, who is leading with many of the elements that you'll see here today. So I'm going to talk about from 3 different perspectives. From design, then factory, and then to the site. So first with design. Many of you have probably heard of the term Design for Manufacturing and Assembly, or DFMA. It's well established in certain markets like automotive, as you just heard, and it's about designing to support a manufacturing approach, which is a new way to think about it from the architecture perspective. So here's an example of a pharmaceutical company called GlaxoSmithKline that's using design for manufacturing to minimize cost while meeting aggressive sustainability goals. So this is a company that has set a goal for zero waste when constructing their new factories. Now, zero waste is very significant when you think about every construction project has about 30% waste. So this is an ambitious goal that they set out. So to achieve this, this company turned to a firm called Bryden Wood, who had created a factory-in-a-box concept. So in this concept, factory parts are manufactured in kind of an IKEA-style, click-and-connect production facility. They're manufactured in one place, and then they're shipped overseas, and in this case to Africa, to be assembled. Now, this process eliminates scrap from the construction process almost entirely, because we have the factory in a box. And there's an estimated 30% cost savings that comes along with that. And the company is able to use local labor to assemble the factory on site, in this case here in Africa. So here's another example. This time is a hospital from a firm from the Nordic Office of Architecture. So imagine if you had a smart assistant help the architect focus design on the way buildings are going to be built and delivered in the future. The assistant can provide an analytic tool that uses specified criteria to help create a library of standard modules. Autodesk is investing in a firm called Project Frog that is helping us develop these kind of tools. Now, the approach doesn't mean that all modules must be the same. So the design team can look at each of these modules, identify similarities, and reduce the number of patterns to streamline the process from design to manufacturing and assembly. And we've invested in another firm called Manufacton that's helping us do just this. And then the final step is to decompose the modules into multiple different elements. And these can either be purchased from a manufacturer or sent to production tools like Inventor, Fusion, Fusion Production, so that they can then be fabricated. Individual modules then can also be combined into bigger cross-discipline assemblies that hold the fabrication intelligence and the assembly instructions. So that's the future of design. Now if we move to the factory, the AEC factory of the future, what will this look like? Maybe something like this. This is the design of a factory that's mass-producing concrete modules. Take a look. I like this example because just yesterday I was seeing this process in a very manual form in Kenya. And according to our industry estimates, creating precast concrete yields 20% savings in concrete consumption and 30% savings in steel consumption. So very significant savings. And of course, these precast parts can also be disassembled, rearranged, and reused in other parts much more easily because of the nature of the construction process. And here's that same factory in real life on a video, mass producing precast concrete modules. So this is a company called Greyform. They're based in Singapore. And by automating the production in a controlled factory environment, they can more accurately plan, procure, and improve the process as they go. They're also able to achieve greater quality, greater sustainability, and greater safety simply by automating this process. Pretty incredible. Now, at the other end of the spectrum is the 3D printing of concrete. And we believe this process can also contribute to the mass production of precast concrete and incredible savings. We're working with a firm called Xtree, and they are helping us streamline the process, moving from BIM all the way through to 3D printed concrete. Talk about the future. And then lastly, let's move to the construction site. What is that going to look like in the future? Now imagine an assembly line on the construction site instead of in the factory, like you see here. The BIM model provides installation instructions, which enables flawless assembly on site. The QR codes are embedded in the modules, enable live tracking for production, delivery, and installation. And this automated job site, it means that data can flow seamlessly from the project through the project site seamlessly for the very first time, which again drives greater efficiency, reduces the waste, and results in a better end product. Robots. Robots also have the ability to transform how we actually are installing buildings on site, helping us be more efficient and more accurate in the execution of our work. And as you watch this, realize this isn't the realm of science fiction. This is the future that we're talking about that is right around the corner. Now take a look at this video. This is, of course, a robot laying bricks. This could be how we build tomorrow at scale. Now, of course, this would mean that the way we do our work will change, right? And in the era of automation and robots, as my colleagues talked about, jobs will change. Some will go away, as has happened in the past, but new jobs will also be created. The future is about humans and machines interacting together, collaborating in new ways to design and make the future. This is the world's first robotic drilling machine. It's 8 times faster than what a manual worker could do. This video is of Skanska, and they're using Nink's robotic drilling machine on a project in Sweden. They claim that it saves an incredible amount of time, but it's also performing hazardous work, so it's more safe for the people on the project. Now, for decades, robots have been able to operate and work in predictable environments, like you would find in a factory. But today, these robots are able to work in unpredictable and unstructured environments, like you find in a construction site. This is changing the way we design and make everything. Now, we're seeing inspiring innovation happen at the construction site on many, many different projects. This video here is ETH, Zurich. They're using robots to build up rebar and lay very complex brick walls, as you see here. Let me pause and let you just watch this for a minute. The complexity of the shapes, how they're using robots to do this. But what you'll see as you watch this video, and may not have noticed, is there's people in the video, right? There are humans that are working alongside these machines, operating the machines, designing the machines. This is the future of humans working together with machines in an entirely different future to design and build new types of structures. But there is a role for people too, of course, and we're going to need to attract more and more people to the AEC profession to build and work together with robots, together with machines, leveraging the power of automation. My colleague mentioned the Autodesk Foundation, and we're working in many different countries across the continent. One of the organizations we work with is called the Africa Design Center, and they're training the next generation of architects, engineers, and designers to design and build a just and sustainable future, leveraging all of the latest tools that we've talked about, whether in the design process, the factory, or on the construction site. And one of the technologies we haven't talked about is the Internet of Things, IoT. The future is about data. But it's not just about consuming and collecting massive amounts of data. It's about using and harnessing technology to better understand that data. It's about transforming data into insights. And that's where the BIM model is so important and so helpful, giving us a single way to look at and understand an enormous amount of data. This enables us to better understand and optimize exactly what we're going to build and the construction site where we're going to build it. Let's look at this example. This is Pilar Technologies. They're using sensors to detect problems at the construction site. So they have a visualization tool which helps understand which zones are safe or unsafe for workers at different times of the day and as the conditions change over time. Now, Autodesk is partnering with a firm called Triax Technologies, which is trying to improve the safety of workers at the construction site, with wearable sensors that the workers can wear that collect and transmit information throughout the day. This enables the team to respond to problems on the site that might need worker assistance or worker evacuation. And they're also using sensors on the cranes, which helps them understand the loads and also understand where it's safe for the workers to be. As we think about the future and building more and more buildings, we need to think about designing buildings with fewer accidents. And with the power of BIM connected with sensors and data like we've talked about, we're able to design and build in a much more safe way going forward. So what does this mean for you? As we move to this automated future, begins with BIM. And when you add the power of the cloud to BIM, everything changes, opening the door to the automated technologies that we've been talking about today. We call this connected BIM. This is BIM plus the power of the cloud. And at Autodesk, our goal is to help put data at the center of everything that you're doing, to connect the digital and the physical aspects of each of your projects. So let me show you what this will look like. This year, we launched the BIM 360 platform. This is a unified platform that connects data across the entire project lifestyle. So all of our authoring tools like Revit and AutoCAD, InfraWorks, and Civil 3D feed data into this platform. And because the platform is built on our developer platform, which we call Forge, third-party developers can also add data to the platform. Simulation data, cost, scheduling, IoT sensor data. And all of our processes, from design collaboration to pre-construction, site execution, and handover and operations, now can run on the single platform. BIM 360 is at the center of the connected BIM process. So no matter who you are, what work you do, or where you are in the process, you can connect to the data through the single platform. And this single platform opens the door to many of the automated technologies that we've been talking about today. So I want to leave you with this. Think about how robots and automation first will transform our whole industry, AEC industry. But then think about how robots and automation might transform your business, like it did with Van Wynen. Think about what you might decide to design and build in this new future, helping you address opportunities and challenges in a radically new way. Think about the skylines of Lagos, Nairobi, Johannesburg, or cities that haven't even been built yet. How will those skylines be different as a result of the technologies that we've talked about? And perhaps most importantly, how will each of you help us build a beautiful, sustainable, smart cities of the future that are healthy for billions of people? This is your opportunity to solve, and we want to help you seize it. So thank you.